Hello guys, and welcome back to my channel. And this is the number one channel for structural insight and a place where you learn, build, and innovate. So today I want to solve example number 4, and this is prestressed concrete design. So the question is on the board and it reads, figure below shows a prestressed beam of inverted T section which is simply supported over a span of 16 meters. The beam is post-tensioned with 3 Prestressed cables each containing 12 wires of 7 millimeter diameter each, placed as shown at mid-span. If the initial prestress force is 1,000 Newton per millimeter square, determine the maximum uniformly distributed load on the beam if the maximum compressive stress in concrete is limited to 40 kilonewton per millimeter square and the tensile stress is limited to 1 Newton per millimeter square. So take the unit weight of concrete to between 4 kilonewton per meter cubic. So this is the section, this is the T inverted or the inverted T section. So as you can see, the bottom width is 600 millimeter and the top is 300 millimeter. So these are the cable 1, 2, 3. So it is placed at 150 millimeter from the bottom, and this width is 300 millimeter and 900 millimeter. So all dimension are in millimeter. All dimension in millimeter. So let's see how we can tackle such a question. So solution, as I said earlier, for you to start solving this question, you will need first to calculate its properties. And property number 1 is the total area, which is equal to, so to get the total area, you divide this section into 2 figures. So figure number 1, figure number 2. And then you will determine the areas of each figures, and then you get the total area. So if we begin with figure number 1, the area is 900 times 300. Then plus number 2, this is 300 times 600. And then you get the area total to be. So let's carry out the operation. This is 900 times 300 plus 300 times 600. So this is 450,000. 450,000, like that. And then after there, we proceed to the Y top and Y bottom. Y bar top and Y bar bottom. So for us to calculate Y bar bottom and Y bar top, again, we will start from the top. You can either start from the top as you proceed to the down to the bottom, or you start from the bottom as you proceed to the top. So I want to start from the top as I proceed to the bottom. So the area of this section number 1 or figure number 1 is 900 times 3000, which is 270,000 times a half of this depth of figure number 1, which is 900 over 2. Then plus, we come to the second figure. So second figure is 300 times 600, which is 180, which is 180,000. Then times 180,000 times a half of 300. So this is 300 over 2 plus 900. And then we'll divide everything by the total area, and the total area is 450,000. So y bar top is equal to, let me carry out the operation. So we have 270,000 times 450 plus 180,000 times a half of 300 is 150. 150 plus 900 is 1050 times 1050. Divide everything by 450,000. 450,000. So the y bar top is 690. This is 690 millimeter. So let's now calculate the y bar bottom. So before I proceed to y bar bottom, as you can see this information, I want to clear here to create space for more calculation. But this question, we have the information in this question. For example, we have a span of 16 meters. We will use this letter, and also 3 fresh net containing 12 wire each of 7 millimeter in diameter. So we'll use this information. And then we have the pre-stressing force as 1,000 Newton per millimeter square. And also we have a tensile stress which is limited to 1 Newton per millimeter square. And also concrete, stress in concrete is limited to 14 kilonewton per millimeter square. And then the unit weight of concrete is 24 kilonewton per meter cubic. So all these I have underlined. We'll use them later in the question. So let me clean. So this is the y bar top. The y bar bottom is equal to the total depth, which is 300 plus 900 minus 690. So let's do the calculation. 300, this is 1200 minus answer. So this is 510. The y bar bottom is equal to 510 millimeter. So if we can indicate on this section, this is how it will look like. So the y top is 690. So around there. So this is 690. And this is 510. Like that. So after calculating the y bar top and bottom, we now proceed to the IXX. the second moment area. So the second moment area, which is I xx, is equal to summation of BD cubed over 12 plus AH square plus AH square. So this one is equal to, again we will start from the top figure. The B is 300 and the D is 900. So this is 300 times 900 cube over 12 plus the area. The area is 900 times 300. This is 270,000 times H square. So H square will be the y bar top minus a half of this, the first figure. So this one will be 690 minus 900 over 2. Then you square like that. Plus, then we'll come to this second figure. So plus, the B for this figure is 600 and the D is 300. So BB cubed is equal to, we have B which is 600 times D 300 cube over 12. Then plus the area for this figure is 300 times 600, which is 180. Then times the H square is, you take the y bar top, which is 690. So this is 690 minus a half of this, and then you add the distance, which will take you to the top. So 300 over 2 plus 900. Then you square like that. After doing so, punch your calculator to obtain the answer. So the answer is equal to IXX is equal to 58.455 times 10 to the power of 9, and this is millimeter to the power of 4, like that. After calculating IXX, we now proceed to what we call section modulus. So this is Z top and Z bottom. So Z top will be I XX over y bar top. So this one is equal to IXX is 58.455 times 10 to the power of 9 divided by y bar top, which is 690. So this one is equal to, divide 690. So this is 84.72 millimeter to the power of 3. So Z bottom is equal to I XX over y bar bottom. So this one is equal to 58.455 times 10 to the power of 9 over y bottom is here, which is 510. So this one is equal to 114.62 millimeter cubic, like that. So remember, our total area, our area total is equal to 50,000, and then is equal to 84.72 times 10 to the power of 6 millimeter cubic, and then 114.62 times 10 to the power of 6 millimeter cubic. So this information will help us later in our calculation. So what follows next is the calculation of the prestressing force, P. Because we have not been given the value of this force P, then it means we have to calculate the value of this force P. So prestressing force P. So for us to calculate this prestressing force P, we need to calculate first the area of the cable. So area of the cables. So remember, in our question, we have been given 3 Prestressed cables, each containing 12 wires, and these wires are of 7 millimeter in diameter. So the area of these cables will be area, first area, the formula for area is pi d square over 4. So this one, so for the 3 cable, so area for the 3 cable is equal to pi times d over 4. Then the cables are 3 times 3. And these cables, each is containing 12 wire. So times 12. And then we will get the area. So let's carry out the operation. So this is pi times 7 square times 3 times 12, then over 4. So the answer is 441 pi. Pi. This is millimeter square. So after calculating the area, we have also been given the prestressing force in the question. Let me check it for you. So the initial prestress force, initial prestress force is equal to 1,000 Newton per millimeter square. So now this is the stress. This is the stress. And you know that stress is equal to force over area. So we are interested in this force. This is what we are looking for. So F, make F the subject of the formula. So F is equal to, this is over 1. It will be stress times area. So our stress here is 1,000, like that. Then times area, this is the area, 441 pi. So you will get, so this is the under times 1,000. And then remember to multiply by 10 to power of -3 so that you can get your answer in kilonewton. So times 10 to power of -3. So the answer is 1385. The answer is 1385. 1385.44 kilonewton. 0.44 kilonewton. Now this is the P. So P is equal to 1385.44 kilonewton. Now you can come here and say P is 1385.44 kilonewton, like that. So we can as well come here and say P is equal to 1385.44 kilonewton. So let's proceed. Now, what follows next is to calculate the eccentricity. And for us to calculate the eccentricity, as you can see, if I can draw this section here, so this is the section, and these are the cables, and then from the bottom part to the cables is 150 millimeters, and then this is the P. So this bottom part is 510. So the eccentricity is this distance from here. This is the eccentricity. So it means eccentricity is equal to 510 from here to here minus 150. So this one is equal to 510 minus 150. So this is 360. So you can come here as well and say E is equal to 360 millimeter. So we now proceed to the stresses. We have the direct stress, which is P over A. So stresses direct stress P over A is equal to, our P here is 1385. So 1385.44, because it is in kilonewton, so you will multiply by 10 to power of 3 to change it from kilonewton to newton. Then divided by the area total, which is 450,000. So this one is equal to 1385.44 times 10 to power of 3 divided by 450,000. So the answer is 3.08. 3.08 Newton per millimeter square. We proceed to PE. We have the PE over Z top. So this one is equal to, our P here is 1385.44 times 10 to power of 3. And then E is 360 over Z top, which is 84.72 times 10 to power of 6. So this one is equal to, let's carry out the operation, 1385.44 times 10 to power of 3 times 360 divided by 84.72 times 10 to power of 6. So the answer is 5.89. 5.89 per millimeter square. And then we proceed to PE over Z bottom. So this one is equal to 1385.44 times 10 to power of 3 times 360, which is E, all over Z bottom is 114.62 times 10 to power of 6. So this one is equal to, again, let's carry out the operation. 114.62 times 10 to the power of 6. So this one is 4.35. 4.35 Newton per millimeter square. So I want to add another information here. So we have P over A is equal to 3.08 Newton per millimeter square. And then we have PE over Z top, 5.89 Newton per millimeter square. Then we have the PE over Z bottom, Newton per millimeter square. So this is PE over Z top, then PE over Z bottom, like that. So allow me to clean here. So we now proceed to the own weight of the concrete, on weight of the concrete, on weight of the concrete, on weight of the concrete. So we know the total area. The total area is 450. And then we also know the unit weight of the concrete is 24. So 24, if you multiply 450,000 times 24, you will get the on weight of the concrete. But this 450 is in millimeter, is in millimeter square. So we are now supposed to change this from millimeter square to meter square. So you will multiply by 10 to the power of negative 6. So this one will be 450,000 times 24 times 10 to the power of negative 6. So this is 10.8. 10.8 kilonewton per meter. 10.8 kilonewton per meter. And then we have the on weight plus imposed load. On weight plus imposed load. So in the question, we have been told to determine the maximum uniformly distributed load on the beam if the maximum compressive stress in concrete is limited to 14 Newton per millimeter square and the tensile stress is limited to 1 Newton per millimeter square. So it automatically means you are supposed to determine the imposed load which is applied on this beam. This is the imposed load. So how are we going to determine the imposed load? So we will assume, so say let's imposed load equals to W, like that. So on weight plus imposed load will be 10.8 plus W. So remember, this is in kilonewton per meter. So remember, this one is in kilonewton per meter, like that. So if we can draw the section of this beam, so the loading is 10.8 plus W, kilonewton per meter. And remember, the length of this beam is, let me check it for you, is 16 meters. 16 meters. Now, the maximum moment M max is given by WL square over 8. So this one is equal to, our W is 10.8 plus W, and then times L, which is 16 square, all over 8, like that. So don't make a mistake of cancelling these two values, 8 and 16 square. Square first 16 and then you can cancel. So this one is equal to 10.8 plus W. 16 square is 256 all over 8. Then you can say 81 832. So it will go here 32 times. Then you can open the bracket. So M max is equal to 10.8 times 32. This is 345.6 plus 32W. And remember the SI unit is kilonewton meter. Now we can determine M over Z top and M over Z bottom from maximum moment. So M over Z top is equal to, our M here is 345.6 plus 32W. So remember this is in kilonewton meter. So you multiply by 10 to power of 6 to make it Newton millimeter. Over Z top is here, 84.72 times 10 to power of 6. So this one will cancel. This will cancel with this. And then we'll divide each term by 84.72. So 345.6 divided by 84.72. So this is 4.08 plus again 32 divide 84.72. This is plus 0.38 W. So this is M over Z top. We now proceed to M. So we now proceed to M over Z bottom. So this one will be, our M remain the same, 345.6 plus 32W. Change it to Newton millimeter. So multiply by 10 to power of 6 over Z bottom is 114.62 times 10 to power of 6, like that, such that these two will cancel. And then you'll divide each term by 114.62. So 345.6 divide 114.62, you will get 3. So this one is equal to 3.02 plus 32 plus 0.28. This is the whole of this is in Newton per millimeter square, as well as this, like so. So we want now to combine the stresses. Now combining, we'll start by the direct stress. Here it is. So we'll start at the top fiber, like that. So the top fiber, we have the direct stress, which is 3.08. Let's write the formula first. So it will be P over A, then PE over Z top. This one will be minus PE over Z top plus M over Z top. So this one is equal to P over A is here 3.08 minus PE over Z top is again here minus 5.89 plus M over Z top is here plus 4.08 plus 0.38 W. And remember, the top fiber is in compression. So we have been told the limit of the compression force is 14 from the question. So check in the question. Let me read the statement for you. So the statement says that determine the maximum uniformly distributed load on the beam if the maximum compressive stress in concrete is limited to 14. So the compression is always on the top side. So this one is equal to 14. And then we'll come to the bottom fiber. Bottom fiber. So for the bottom fiber, we'll have P over A plus PE over Z bottom plus M over Z bottom. Now this one is supposed to be minus, not plus. Minus, that's for the bottom part. So let's continue. So the bottom fiber, P over A is 3.08 plus PE over ZB is 4.32 minus M over ZB is 3.01 plus 0.28, and the limit for the tension is equal to 1. So the bottom part is in tension. So this one is equal to 1. So let's now simplify this expression. So 3.08 plus 4.35, 7.43. This is 7.43 minus 3.01. I'm opening the bracket, then minus 0.28 W is equal to 1. Again, 7.43 minus 3.01. You'll get 4.42 minus 0.28 W is equal to 1. So this is equation 1. Let's come again and simplify this. So here you have 3 3.08 minus 5.89 plus 4.08 plus 0.38 W is equal to 14. So 3.3, let's put like stamp together. 3.08 plus 5.89 plus, no, this is minus 3.08 minus 5.89 plus 4.08. So 1.27 plus 0.38 W is equal to 14. So this is equation 2. Equation 1, equation 2. Now we can solve this equation separately. So this is equation 1 and this is equation 2. So let's begin with equation 1. So we have 4.42 minus 0.28 W is equal to 1. So let's 1 cross to this side and then negative 0.28 to the other side. So we'll have 4.42 minus 1 is equal to 0.28 W. So 3.42 is equal to 0.28 W over 0.28 over 0.28. So which imply, let's call it W1 is equal to 3.42 divided by 0.28. So this one is equal to 12.21 kilonewton per meter. And then for the second one, this one, you can also do the same. So this one we have 1.27 plus 0.38 W is equal to 14. So this will cross. 0.38 is equal to 14. Let's just subtract it direct. So this is 14. 14 minus 1.27. 14 minus 1.27, you get 12.73. Remember, this is W. So over 0.38 over 0.38, which imply we call it W2 is equal to 12.73 divided by 0.38, you get 33.5 kilonewton per meter. Therefore, the safe load, the safe imposed load is equal to 12.21 kilonewton per meter. So you take the one which is less, which is lesser. So 12.21 kilonewton per meter is the safe imposed load. And this question ends here. This is the end of this question. So thank you for your time. Thank you for watching this video. And for those who have not subscribed to the channel, please subscribe and hit the notification bell so that you may be the first person to be notified. So we meet again in my next session.